In order to solve some of these problems, you needed to have a specific technique. And this technique is called changing bases. So basically, when we've done any of our stuff, we've said that bases have to be the same. But in some of those questions that you just had, they weren't. So we have to work out how to make them the same. So I'm going to start with a really easy one. Okay, so something like this. Normally we'd be trying to equate the indices to solve the problem, but we can't equate the indices unless the bases are the same. So we have to say, okay, how can we make the base the same? Usually it will be a multiple or a power of it. So this 9 here, we can change into being 3 squared. Alright, so now we've got those index rules coming in. So 3 squared is 3 to the what? 3 to the 4. So now that the bases are the same, we can say, so therefore x is 4. Alright, so that's a really easy one. Let's have a look at another one. We could do this particular one, and the last one, by actually finding out what 8 squared is, and then finding but what we're trying to do here is use the power of exponential rules to make those bases the same. So to make these two the same, what would the base be? 2. Alright, because they're both part of the 2 power, 2, 4, 8, 16, 32, etc., etc. So this one is 2 squared to the power of x, and this one is 2 cubed to the power of 2. Now we prettyify the top, so we get 2 to the 2x is equal to 2 to the 6, so 2x is the same as 6, x will be 3. Right, so now one that looks similar to the ones that you couldn't do in the starter. How about this one for size? Oh no, I like that other one. Oh, so here comes a really nice merit, maybe even excellence, but I'm saying probably merit. So what they're asking you first of all is to recognise that both of the bases are actually in what power function? 5 to the power of 1 is 5. 5 squared is 25. 5 cubed is 125. So these are both part of that 5 power function. This one and this one. Alright? So when we get rid of everything, we've ended up with 2x plus 1 is equal to 3x squared. What's the secret about solving quadratics? Put them all on one side. So we're going to get 3x squared. That was already there. I'm moving this over, so it's minus 2x. Moving this over, so it's minus 1 equals 0. And then we would try a few things to solve this. I'm just going to write solve here, because as yet, we haven't gone far enough in the solving realm to find the answer for that. But we've now got something we can solve. Alright, so I'm going to leave that there for another day. But I'm